So question 11, the next part. Which energy changes have taken place between X and Y? Between this point to this point. What are the energy changes taking place? So as you know, when the object is rolling down a hill, it has got gravitational potential energy. And then as it rolls down, as it is moving, at this point, it would have kinetic energy. And you find a slope here, that means it would slow down at this point here. And what causes it to slow down is the friction between the wheels and the road. And that friction will also release thermal energy. So gravitational potential energy at this point, kinetic energy here, thermal energy here. So the correct option would be A and not B, because at point Y is about to stop or about to slow down. So the correct sequence would be this: gravitational, kinetic, and thermal. Question 12. How has this change affected the force and the pressure exerted by the block? As you see here, it is the same block. It's not the same different block. It's the same block that has been placed at a different position. And it's talking about the pressure and the force. And we know the equation pressure is equal to force divided by area. So firstly, what happens to the force? We know that force is acting downwards in both the cases, and the force that acts downwards, it's nothing but the weight. So the weight hasn't changed in both the cases because the mass hasn't changed. The mass remains the same because it's the same material, the same flat rectangular block. So that means the weight of these blocks never changes. So the force at which it is being pulled down has remained constant. So the force remains unchanged. So it's either C or D. So what happens to pressure? What happens to pressure when the force remains the same, but the area onto which it is acting? In the first case, you see a small the block is acting on a small amount of area. So let me put a small a there. And in the second case, the surface area of the block has increased. So it's a greater surface area that is acting on that surface. So in the second case, for the same amount of force, there is a greater amount of area. So in these two cases, what would happen to as the surface area increases? As this happens, when the area increases, when the denominator value increases, obviously the result would be smaller. So the pressure would be decreased. So force remains unchanged and the pressure would be decreased. So the answer is C. Question 13. Talks about the atmospheric pressure. Now, which row states that what happens to the pressure at point P and what happens to level L? The condition is the atmospheric pressure is decreasing. The atmospheric pressure is decreasing. So as the pressure decreases, yani the pressure over here, the air molecules, I'm talking about the atmospheric pressure, yani the air surrounding it. So the pressure decreases. When the pressure decreases, what do you think will happen to the level L? So they're talking about two things: pressure at point P and to the level L. What happens to level L? Number one, as the pressure, initially the pressure was greater. This is the atmospheric pressure, pushing it downwards. Now, as the pressure decreases, as that pressure decreases, you can expect the level to raise here because the force that was the pressure that was pulling it down has decreased, so the level of the water from the mercury would increase. So as the level here increases, what would happen to this level? Obviously that would decrease. So the level L would fall. So you have two options that tells you false. Now we have to find out what happens to pressure P. You may have learned about barometer. This barometer, this part here, what you see here, the empty level here, just above the mercury level, that is actually made a vacuum always. There is no air in there. The air is completely removed, and that has changed into that part is always kept as a vacuum. So when there is vacuum, there is no pressure. There is no pressure. When there is vacuum, there is no pressure. So that means the pressure at point P would stay the same. C is the answer. Next question. Which row shows two changes that will both cause a liquid to evaporate more quickly? So obviously, the first thing is talking about the change in the surface area. So if you leave a liquid in a vessel which has got smaller surface area and then with a larger surface area, obviously the one in the larger surface area would evaporate quickly. So change to the surface area of the liquid. It would increase the evaporation. So the question is, which row would cause it to evaporate more quickly? Change to the surface area. You have to increase the surface area. So you have options either C or D. Now change to the speed of the fan. What is the effect of the fan? So if you keep a fan close to it, the air that is blown by the fan, it would blow it that direction. Let me redraw it. So let's say this is the vessel where the evaporation is taking place. And when the evaporation is taking place, what happens is there are air molecules over here, and now the evaporated molecules would occupy the space in between them. Now, if the air molecules, after some time, this would be saturated because there is no space for the evaporated molecules to occupy. In that case, the evaporation would decrease. But if you now let a fan to blow this air, what would happen? This part of the air molecules are removed from that position. So there are certain new air molecules coming to that place. The new air molecules would take that spot. Now there is more space for the evaporated molecules to fit in those spaces. So as you increase the wind speed, there are more air molecules coming into that place. So the evaporated molecules are taken away. So there is more space for more water molecules to come and squeeze in. So change to the fan speed, you also have to increase it. Surface area, you increase it in order to evaporate it quickly. So the answer is D. Which graph shows the pressure of the gas during the process? The process is the temperature has been increased. The temperature of the gas in the cylinder is slowly increased. So as you know, as the temperature increases, so for example, if this is a vessel and there are air molecules in it, if you add heat to it, these molecules would gain energy. As they gain energy, they start moving faster. When they start moving faster, they would cause they would hit the walls of the container very frequently, which would increase the pressure. So as the temperature increases, the pressure of the cylinder will also increase. So there are two graphs here that shows you that relation. As the pressure increases, the time along the time. Yani the temperature is kept increasing. It is being heated. So the pressure would also increase. But there are two graphs here, B and C. B is incorrect because it says the pressure is starting from 0. So the correct option is C. In order to pressure to start or pressure to reach the level at 0, then it must reach the temperature of absolute temperature, which is minus 273 degrees Celsius, which is not the case. In order to pressure to reach 0, this has to be the temperature. But that's not the case. So there is a little bit of pressure at the beginning, but that pressure kept increasing as the temperature was increasing. So C was the correct answer there. Frequency of the wave is doubled. Interesting question. Speed of the wave does not change. What happens to the wavelength of the wave? So the speed should not change, and the speed is a result. We know that speed is equal to frequency times wavelength. So speed does not change. The frequency of the wave is doubled. So let's put, instead of f, let's put it as double the f. So it is 2 times the f. Now the question is, what would happen to the wavelength? In order to, what would happen to this wavelength when the speed is doubled and when the frequency is doubled, but the speed does not change? Think logically now. Let's say you have got 10 equals to 5 times 2. Now what they're saying is this 5 is doubled. This 5 is doubled. But 10 should remain the same. So if 5 is doubled, let's also make it 10. 5 is doubled, 5 times 2 would be 10. Times, what would happen to this 2 in order to get the same answer 10? You turn that 2 into half of it, should be 1. So 10 times 1 is 10. 5 times 2 is also 10. So in this case, what we could do to make that speed remain the constant is we have to half that wavelength. So when you reduce the wavelength to the half, when you reduce it to half, this 2 and this 2 gets cancelled. So the velocity would still remain the same. So what happens to the wavelength? The answer is it halves. So at which time it become completely liquid? We're talking about a solid that is being heated. So when it starts to heat here, at this point it is being heated. So this phase over here, when the temperature is not changing, that is a phase when the solid is turning into a liquid. Okay, so at this phase you will find some of the matter, some of the solid is remain a solid, and some of the solid has converted to liquid. So you'll find solid and liquid at this phase. When is it completely liquid? It would be from this phase to this phase. It's completely a liquid. And the curve there, if you continue there, that's the point when the liquid will be turning into a gas. So from C to D, at which time it become completely liquid again. So at C, it has just started to turn into a liquid, but at D, it is completely a liquid now. Now, after the D point, you would see the flat line again, which means at that point, the liquid is started to turn into gas. So D should be the answer, not C. D is the right answer. Which part of the beam heats up more quickly during the day and which part cools down more quickly at night? This question is on a very simple concept that all the black surfaces are good emitters. They are good emitters as well as they are the good absorbers of heat. So part heating up more quickly would be black. Part cooling down more quickly would also be black. Answer is A. So as the liquid is being heated, how does the density change and what is this energy transfer process? So if this is the vessel which contains water in it, as you heat up, as you heat up, the water molecules here gain energy and they would spread out. They would spread out. So if you heat any let me put that in a detailed way. So let's assume a closed container now. Let's say it has got 5 air molecules, and the same closed container, when it has got 5 air molecules, they would have the same amount of density. But if you start heating it up, if you start heating it up, the air molecules will gain the energy and it would start to move farther apart. It will start to move farther apart. And the equation for density is mass divided by volume. So when you heat it up, it is the same amount of mass, but it has occupied more amount of space, so that means the volume has increased, which means in that case the pressure would decrease. So when the volume increases, the pressure would decrease. So if you consider only this part of the air water molecules, when you heat it up, they would gain energy and they would move to the surroundings. Okay, so that at that point, the amount of for the same amount of mass. So now when you heat these air molecule water molecules, there will be more space in between the water molecules. So the volume of these the space they take up has increased. So when you calculate mass divided by volume, obviously the density would decrease. So as the density decreases, what would happen? Since they become less dense than the surrounding water molecules, they would float, they raise to the top. They raise to the top. So in this case, the water molecules, they are heated, they become less dense, so they raise to the top. As a result, the the molecules which were on the top, they are more denser than compared to these raised molecules, so they would sink to the bottom. So this process, as we have studied before, is called as convection current. Convection current is produced, so the process is convection. So the density is decreases, the density of the water molecule decreases, and the process is convection. The answer is B. Question 20. This needs a little bit of detailed explanation. Let's go back to the basics on the ray of light passing from rarer to the denser medium. So what happened in that case? So consider a piece of glass, and that's the line of normal, which is always drawn perpendicular to the surface. And then imagine a light ray passing or incident on that glass. So if you have incident a light ray through this, what would happen to that light ray as soon as it enters the glass? We know that air is a rarer medium, whereas glass is a denser medium. So when the light ray passes from a rarer to the denser medium, it slows down. It slows down. So when it slows down, this was the supposed direction of the light, but it doesn't go that way. Rather, it would, since it is slowing down, it would bend towards the normal like this. So remember that when the light ray is going from rarer to the denser medium, it slows down, so it bends towards the normal. On the flip side, if you make it the other way around, for example, if you say it is going from now, it's going from a denser medium to the rarer medium, then the opposite would occur. When it is going from denser medium to the rarer medium, the light would speed up. That means it would bend away from the normal. So let's suppose these are two different medium. Let's say it is going from a glass, which is a denser medium, into water, which is a rarer medium. So in that case, instead of light going straight, instead of following its straight path, it would be, this was the supposed path of the light. It wouldn't happen that way. So it would bend away from the normal because it gains speed. So it would bend in that direction. It should be a straight line there. It would bend in that direction. So remember, when it is going from a denser medium to the rarer medium, it would speed up, so it would bend away from the normal. Coming back to the question, it says the water is moving from deep water to the shallow water, which means in the deep water, it is fast. In the shallow water, it slows down. So apply the same rule here. When it is going from, when it is slowing down, that means it would bend towards the normal. It would bend towards the normal. So first challenge is you have to assume the right line for the normal. Where would you draw the normal here? Look, this is the boundary of the surface. So the normal is always drawn perpendicular to that surface. So I can't actually draw an exact straight line on the PDF, so I'm just drawing this. So let me draw that way. So that's the line of normal. And where is the direction of the wave here? This is the direction of the wave. So as it is going from, as it is slowing down, as we know, it's the wave is slowing down. So if it is slowing down, then it must be going towards the normal. So the supposed direction of the wave is this, but it doesn't go that way. Rather, it should be bending towards the normal. This should be the actual position of the wave, the actual direction of the wave. So where do you see that? In which of these figures do you see that? So obviously the first one, you see the wave going straight through, which is not the case. It should be bending towards the normal. Okay, so if you draw the normal line, so let me erase these things. This first one is not an option. So let me draw a normal line there for this one. That's a line of normal. And this is the direction of the wave. It should have been bending towards the normal. So instead of going that direction, it should have bent towards the normal. That's not happening. Rather, you can see that the wave is going in that direction. So that's also not an option. The third one, the A and D, you can ignore it because you can see the wave is passing straight through. So that is also not an option. So the correct option is C. Look at that. This is the line of normal. That's the direction of the wave. Instead of going straight through, the wave is bending towards normal. So C is the option. Which waves travel at the same speed in the vacuum? We know that all the electromagnetic spectrum, the electromagnetic radiation starting from all the waves like infrared, microwave, radio waves, they all are infrared. They all are electromagnetic radiation. They all have the same speed, which is 3 times 10 to the power of 8 meters per second. Whereas sound waves, it travels at a different speed in solids, different speed in liquid, and in gas. So sound, it does not have the same speed as that of the electromagnetic radiation. So which waves travel at the same speed, same high speed in the vacuum? Anything that is where the sound is not mentioned is the right answer. So sound is mentioned here, not an option, not an option, not an option. A, we see only the electromagnetic radiation. 22, where most of you have done the mistake here. The diagram represents three rays passing through the lens. Which type of image is formed? So firstly, how do you illustrate an image here? You can see all the three rays passing, they never meet. If you extend them, they never meet. So in this case, what do? We extend it from the other direction with a dotted line. Remember, you use a dotted line. So you have to show as if the ray is coming from that direction. So this ray here, you have to show as if it is coming from that direction. Likewise, the third one, sorry, I made a mistake there. So you have to show as if these rays are coming from that direction. So you always have to use a ruler in this case. Since I'm using a PDF, I can't actually use a ruler there. And if I extend this one, it's as if it is coming from that point. Likewise, using a ruler, if you extend this, it would be reaching the same point there, over here, which means the arrow is pointing upwards. Now, whenever you find images like this, number one, it is you get the image using the dotted lines. That's when we call the image is virtual. And you would see this image not in the other side of the lens, but you see that along the same side of the lens, which means the image is virtual. And as you see, the image that you have drawn is obviously larger or bigger than the object itself. So the option is virtual and enlarged. Which row contains correct statement about angle x, about the optical density of substances Q? This question is related to the total internal reflection. For the total internal reflection to take place, there are two conditions. The light ray must be going from a denser medium towards a rarer medium. That is first condition. Number two, for the total internal reflection to take place, the angle of incidence must be greater than the critical angle. So when do we say the angle is, when do we call as an angle critical angle? When the incident ray, the ray of light incident, if its angle of refraction is 90 degrees towards a normal. I repeat, for the ray of light, if the angle of refraction makes 90 degrees with a normal, that's when we call it as critical angle. If the ray of light, if the ray of light is incident in such a way that it's slightly bigger than that critical angle, then the light would undergo total internal reflection. In simple words, when the angle of incidence is greater than the critical angle, when the angle of incidence is greater than the critical angle, the total internal reflection takes place. So the first condition is it has to go from denser medium to the rarer medium. The second condition is the angle of incidence must be greater than the critical angle. So substance Q, which is this one, should be less dense because that's a condition. It has to go from denser medium to the rarer medium. So it's less dense than P. So you have two options. What about angle X, which is the incident ray? It should be greater than the critical angle. So here is option. So visible light has a frequency of approximately this. Frequency of M is this much, N is this much. Which type of radiations are M and N? As we know, when you go from radio waves towards the gamma rays, the frequency f increases, which means the wavelength, it decreases. Right? Now look at the values you have. It's talking about frequency. 5.0 10 to the power of 6. Frequency increases along that direction, which means f is smaller here, talking about frequency, and f is greater towards the other end of the spectrum. So 5.0 times 10 to the power of 6 would be falling here, and 5 times 10 to the power of 15 would be falling towards the other end. So which one is smaller now? M, what are the possibilities of M? So M could be, if you take M as a smaller frequency, the one with smaller frequency have radio waves as an option. So M could be radio waves. And the one that comes after it is infrared. I said the frequency increases if you go from this point radio to gamma. That means and another option here, another clue here, you have got the visible light spectrum is 5.0 times 10 to the power of 14. Okay, and this one is 10 to the power of 15. 5 times 10 to the power of 15, that means it is next to the visible light, which means it's UV. So the correct option is not infrared. You have to choose ultraviolet. So B is the correct answer. 24, the answer is B. Which group contains only non-ferrous? Ferrous, it refers to iron. You may recall that the periodic table, the symbol for iron is Fe, which is actually derived from this term ferrous. So which group contains only non-ferrous? Yani it does not contain iron in it. It does not contain iron in it. The option here is brass, copper, and lead. Because steel is something that is made up of iron. So steel and iron is already there. Iron is already there. So B is the correct option. 26. Which combination of materials gives the shortest time for the sound to reach the microphone? If it has to have shortest time, that means it has to have a greater speed. For the sound to travel at a greater speed, we know that sound travels fastest in solids. So that means which of these materials, material 1 and 2, if they are both made up of solids, that means it will travel the fastest. So C is the correct option. The amplitude and frequency of each of the sound waves given in the table. How does sound Y compare with sound X? Remember, amplitude of the sound has to do with the loudness of the sound, whereas the frequency of the sound has to do with the pitch of the sound. So in this case, you see that how does sound Y compare with sound X? Sound Y has got a greater amplitude comparatively and lesser frequency comparatively. So if it has got greater amplitude, so that means Y would be louder than X. Okay, Y is louder. So you have two options. Y is louder. Frequency, which is related to the pitch, is lower than X. So it has a lower pitch, which means B is the correct answer. Magnetism, an easy question. Which diagram shows magnetic poles included in the nails? So this is a bar magnet. That means when you attach a nail to it, a magnetic field is induced in the nails, which is just exactly opposite of the pole that is facing the opposite of the the magnetic pole. So this end would obviously be the north pole, which means it will attract to the north pole is induced here so that the nail gets attracted to the magnet. So the other end would be south, obviously. And so if you bring in another nail, that nail would also, a magnetic field would be induced, which is opposite so that it can stick to it. So A is the option. All the other options, it doesn't make any logical sense because south and south wouldn't attract. North and south would attract, but again, south and south wouldn't attract. Again, south and south wouldn't attract. The next question is about ohmic resistors. For the ohmic resistor, the condition is as you increase the voltage, the current will also increase through it. That is ohmic resistor. Which two graphs shows the characteristics of an ohmic resistor and a filament lamp? Whereas in a filament lamp, you would see initially, as the current increases, as a voltage increases, the current would also increase. But after the filament gets heated, after the filament gets heated up, the current flowing would gradually start to decrease. So X is definitely an ohmic resistor. So you have two options. And the one that is a filament resistor would be Y. Okay, a wire has a certain electrical resistance, the diameter and the length changed. Which pair of changes must cause the resistance of the wire to increase? Let's talk about with regards to thickness and with regards to length. If the wire is thicker, let's assume two wires. One is thick and the other one is thin. Which wire would cause more resistance? It would be the thin wire would cause more resistance. Why? Because in the thick thick wire, the chance for the electrons to move is more. It can squeeze through it. Whereas when the wire is thin, it has to pass only through that specified area, which would be blocked by the atoms of the wire itself, the electrons present in the wire. So a thinner wire would have more resistance. So which pair of changes must cause the resistance of the wire to increase? With regards to the diameter, you have to decrease it. So when you decrease the wire, it will be more resistance. So you have options A or B. So C and D, you can strike it off. And then with regards to length, let's imagine a thin wire, a shorter one with the greater length and the other one is shorter length. Then the length which is greater has got more resistance. This has got more resistance. Why? Because the charges has to cross over the large part of the length. Whereas if it is a wire is shorter, then the electrons, the charges could only travel through a shorter distance, which would experience a less resistance. So increasing the length would also increase the resistance. So change in length should be increased. The option is B.